In this video, we shall consider yet another example. And in this example, we're going to be considering the data in the table below, which shows the results of a national study of 137,243 US men that investigated the association between cigar smoking and death from cancer. So, current cigar smoker means cigar smoker at the time of death. So you have current cigar smoker, you have former cigar smoker, and never what smoked cigars. And I would like to take the row totals and the column totals because this will be very useful for us. In this case, the row total here is 121,529,7848, provided this is not, this first number is not there. So we should, that was a typo there. Good. And for this one, we have 136, excuse me, we have 7866. And for this column total, you have 1014, and this is 136229. Based on this table, if an individual is randomly selected from this study, what is the probability that it died from cancer? The probability of died from cancer, I would just say cancer, that would be equal to how many of those who died from cancer, which is 1014 out of the grand total of 137243. Okay, and we can leave the results in that form or in decimal form, which will give us 0.0739. Next, what is the probability that the randomly selected individual was a current cigar smoker? So for current cigar smoker, that would be 7. So probability of current, that would be 7866 divided by 137243, which is same approximately as 0.057314. Next, if an individual is randomly selected from the study, what is the probability that the person died from cancer and was a current cigar smoker? So that would be the case of looking back at this table. We're looking at instances, the number of instances where the person died from cancer and was a current cigar smoker. So what would that be? That would be 141 of them. So this is 141 out of 137,243. So that should give about 0.001027. And next, if an individual is randomly selected from the study, what is the probability that I died from cancer or was a current cigar smoker? The use of the or here tells me that I am likely to consider the general addition rule. So I'll look at the probability of just cancer plus the probability of current and the probability of cancer and current. We have these results earlier. Probability of cancer is this value, 1014 over 137243, plus probability of current, that is 7866 out of 137243, minus probability of current and cancer is 141 out of 137243. That should amount to 8739 over 137243, or approximately 0.06363674. Then we proceed to a final application problem where parts and materials for skis made by Downhill Adventures Company are supplied by two suppliers. Supplier A's materials make up 30% of what is used, and while what? Supplier B providing the rest. Past records indicate that 15% of supplier A's materials are defective and 10% of B's are defective. Since it is impossible to tell which supplier the materials came from once they are in inventory, the manager wants to know which supplier most likely supplied the defective materials the supervisor has brought to his attention. Provide the manager this information and use your knowledge of probability to help narrow down the suspect supplier in this scenario. So, this is trying to make a decision in the face of uncertainty. So, to get that done, all we have to look at is we're interested in who likely supplied a defective material. So let us take the first step of organizing all this information in a tree diagram. If I pick a random defective material, it could come from supplier A or it could come from supplier B. Now, for any such material that is being used, supplier A makes up 30% of what is being supplied, so 30%. The remaining 70% comes from supplier B. Then from supplier A's, there are defective ones and there are good ones. And according to the information provided, let me erase this. 15% of supplier A's materials are defective, so 0.15 is good, and the remaining 85% is, 15% is defective, the remaining 85% of supplier A's materials are good. Whereas for supplier B, 10% of supplier B's are defective, and the remaining 90% are good. Okay, so the next step we'll take in solving this problem is to compute the total probability or proportion or probability of all defectives. Okay, as long as we're talking about a defective material, it could come from supplier A or it could come from supplier B. So in this case, that means we're looking at gathering all the proportion from supplier A and that of supplier B. To do that, we say probability of all defectives, total probability of all defectives that could come from defective and from supplier A plus defectives and from supplier B. To calculate the first part, so you have 0.15 multiplied by 0.30 and plus 0.10 multiplied by 0.70. This comes from the first path, and this comes from the second path, multiplying those values together. And ultimately, we have 0.045 plus 0.07, which will give us 0.115. The final step, who has the bigger chunk of the probabilities? It is obvious that of all of the defectives, 0.045 is lesser than 0.07. So there's no doubt that majority of the defectives appear to come from supplier B. So 0.07 out of the total proportion of defectives exceeds Exceeds 0.045 out of 0.115. So this indicates that the most likely suspect supplier is as supplier B with a higher a higher amount or proportion of defectives. In this way, we have been able to help narrow down the most likely suspect, considering previous or prior information.